Okay. Hello, everybody. I just want to briefly introduce myself. My name is Mike. I am an electrical engineer working for a company called Sanctuary Software Studio out in Ohio. And this video series is mainly for my personal side project, side hustle, if you will, the Magic Forge. So I am fortunate that my hobby, one of my primary hobbies in life, also aligned with my chosen career path, working with electronics design and development. Um, so I just wanted to mention that, you know. So these videos will be kind of broken up. I have no idea of a schedule yet. This is new to me. I've never done any of this before, so bear with me, and we will see what we can do. So this video series I'm calling from breadboard to manufacturing, or breadboard to market. That's probably better. Breadboard to market. And this is the first episode where we will just cover the very basics, the goals, what I'm looking to accomplish with this, the ins and outs and whys. So I have an extensive background in manufacturing, which includes the standards such as ISO for basically manufacturing excellence, uh, quality control, and everything associated with it. So the goal of this video series is to teach, to educate, to get the knowledge that I've gained over decades of electronics and manufacturing experience, along with ISO, the quality management system, as well as project management, possibly even Six Sigma, which is problem solving, uh, to try to create a cohesive concept for anybody who has ideas, who has dabbled in electronics, to possibly move from a concept that you've thrown together on a breadboard to something that you may actually want to throw on the market. Maybe throw on eBay, throw on Etsy, even Amazon, or through your own storefront through something like Shopify. So that is the goal of this video series. Uh, we will be working hand in hand developing a product. The concept is I like working with automation equipment and I like working with stepper motors, but I also hate developing and throwing together a breadboard with all the wires, all the jumpers, everything necessary to facilitate interfacing with a stepper motor to test various things and to do various functions. So we are going to go down a journey of developing a modular development kit, so to speak, that could also be used at the end of the day to throw into a final product. It'll be fully functional with all the, hopefully, bells and whistles that it could be actually usable for something. That at the end of the day could be custom coded for whatever particular application that you need it for, be it driving something like a conveyor belt, moving a gantry back and forth, such as like the head of a 3D printer or something, whatever you decide to do. So the plan is to develop two versions of this, one built around an ESP32 that we might even be able to incorporate Bluetooth into, maybe even Wi-Fi, I'm not 100% sure. And then another version that will be built around a PIC microcontroller, because they fit in multiple different various situations, scenarios. So the first one will be the ESP32 based. Now, I'm not a coder. I'm not a programmer. I need to put that out right here. So I will struggle and kind of smash my way through this. I have gotten some things to work. Some things I haven't gotten to work yet, and it will be a journey. Now, one of the things I want to make clear before we proceed on this journey is I will be showing you a lot of different software packages, services, maybe even products that I use throughout the development process, because I plan on showing everything from start to finish, including even assembling and building. We're gonna start with basically the project, kickoff, the any documentation, and align them with ISO for that, um, as best as we can, because I have a firm belief that if anybody wishes to head down the manufacturing path, to actually go down the path of designing products to put on a marketplace, the best way to do this, in my personal opinion, based on my experience in the field, in various manufacturing fields, is to incorporate ISO from the beginning. Even if you do not plan on becoming ISO certified, one of the best things I believe for a company or a fledgling organization is to incorporate the practices from the get go as best as you can. Because at the end of the day, ISO is to help you produce the best possible product to deliver to your customers and keep them happy. And through the artifacts that ISO processes create, it will also create a sort of protective environment for you. You will have traceability. You will have artifacts that you can go back to in case of questions, in case of problems, in case of maybe even legal action. You can say, no, here's all my artifacts. Here's all the documentation on this. This is all the testing that we've done. This is all the development. Here's all the proof. This will give you proofs of everything you've done. And it's a great methodical way to stay organized throughout the business structure, throughout what you're trying to accomplish. And I just feel it's the best to do it from the get-go. And it's highly teachable. It's repeatable. That way, if you become a company that grows beyond one or two people, everybody can be on the same page. No questions, no ifs, buts. Everybody knows what they have to do to get the job done. Plus, it creates a foundation to train new hires much easier. Much easier. Because you have all this documentation. You can use new employees down with this documentation. They can learn the core ins and outs of your company, of your processes, of what you do, even your products, before they even lay a single hand on anything, before they even begin. So I just find this a great practice. And it just creates discipline. That way you can do the best you can and deliver the best you can to your customers, as well as resolve problems like manufacturing failures, warranty issues, RMAs, everything. It provides all the framework, so you have a streamlined process to handle all that. So one of the things I want to say is, disclose, I will also be using Copilot to help organize thoughts. AI, it's a great tool to help format documents, to help keep them organized within this, in this sphere, to make sure that everything stays aligned, everything stays linked, everything stays cohesive and formatted, so you have the familiarity across the board. I am not sponsored or endorsed. I'm not endorsing any particular product. Nobody's paying me, to create these videos. I'm not opposed to that down the road, but right now, these are just products and services that I use, will be using, and will be learning to use. So I am not endorsing or telling you to buy any products or services. If you can't afford them, don't buy it. Electronics can be an expensive endeavor, and if you can't afford to spend the money on it, don't, because it can rapidly increase in cost as you develop prototypes and have to do different board spins. Parts can be expensive. Some parts are upwards to $10 a piece, and when you're building in batches of 5, 10, 50 boards, your initial investment can get expensive. So be mindful, and that's another reason to stick within a process. Develop processes, have back-end alignment as early as possible to try to push yourself into all this different stuff. So professionally, for the company I work for, I use Altium Designer. Great software package. I absolutely love it. But I will not be using it for this video series. For my side hustle, my side project, the Magic Forge, I personally use Circuit Studio. Great software package, but you still have to buy a license to use it. The goal of this video series is that anybody who's played around with a breadboard, who has a great idea, something they like to try to market to get out there, they can do it as low cost as possible, and still capture everything, all the data, and keep it organized with tools that are highly usable, very popular, and low cost to free. So one of the tools we will be using is KiCad. This will be used for schematic capture and PCB layout. I have very little exposure to the software package, so I will be learning it alongside of you. If any of the viewers know how to use KiCad and spot mistakes, positive feedback is welcome. Please, negative comments, trolling will not be tolerated, and we will deal with that as we go. This is about learning and moving forward and taking ideas, sharing them, and doing something with them. So we'll be using KiCad for the schematic and PCB layout. For anything that would involve 3D printing or creating shells, maybe even documentation that you would use like a 2D CAD for, we'll use FreeCAD. I used to use this a long time ago, but now I use Fusion for all my 3D development work for 3D printing. But I should be able to pick up FreeCAD, hopefully, again. But it's a great program. It's a great software package for doing 3D development for printing, 3D printing especially. For file management, for some documentation such as bill of materials, things that we might need to export to a CSV, we're going to use LibreOffice because it has pretty much the same functionality as the Microsoft Suite does, but again, it's free. You can use it, you can download it, and it's a great software package. I used to use it all the time until I switched over to Microsoft because unfortunately business uses the higher end packages. Though Microsoft is a Microsoft Word and Excel, their whole Office suite is pretty much the standard de facto used in the industries today by most major corporations. But the great thing is LibreOffice is compatible with most Office file formats. So we'll use this for CSV files, for any like manuals or documentation we have to specially format and send out with our products. Then we're going to be using something called Draw.io, which is great for flow charts, organizational charts. The primary function we're going to use this for is, at least for starters, is to kind of organize the project, kind of create a block diagram of the whole project and what we're intending to do, what we need for it. So it's a great tool. I've used it off and on many times for different projects. It's not like a daily software package that I use, but it's really nice. Then we also need Visual Studio Code. Great software package. Like I said, I'm not a coder. I actually started software development in the Arduino IDE, got hooked, was able to make a bunch of small projects that did some cool stuff. But over the years, I got into using Visual Studio Code to do bare metal coding on projects. Down the road later, we'll need the microchip IDE, the MP Lab, but that'll be later, and we'll bring all that up because there's additional hardware we'll need for that to do the programming. But the great thing about ESP32s is you don't need special programming tools like a PicKit or something. So we'll be using VS Code. Then I'll also be showing you to use a software package called Odo. Now, I use this for my manufacturing, resource planning, MRP. I use this for inventory control. I use this for bombs. I use this to manage the projects. It's a really great software package. There's a free community version that I recommend to download. You can do this in, so you want to use the community version. You can install it and run it locally on your local machine, or you can set it up on a separate server. You could even use their online service, but I prefer local because I have a little bit better control over uh, the files, what I get to save, and all that. Then I would say to to get comfortable using websites such as Mouser. They're a electronics component provider, a vendor. I do a lot of my purchasing through them. It's just personal preference. I've used them for years for my electronic parts. There's also DigiKey, which is very common, another great company to order parts from. And then also Newark Electronics, uh, another great site, another great company to get parts from. Uh, One of the issues you run into is vendor A will have these parts on hand, but they'll be low in stock of another part that you need. So you can always try the other ones to find them. Great sources, great sources. Newark is really great for stocking JST components. Really great for that. And then another service I use is JLC This is the company I go to have the circuit boards manufactured along with the solder paste stencils. So I send the design files to them, uh, put in the specifications, and order the boards. And usually it's about a week and a half turnaround. Uh, Unfortunately, with the tariffs, things are a lot pricier than they were. Uh, but again, you know, it's just the nature of the beast. So you don't have to use any of these software packages. I'm just going to be running through because it helps keep things organized as far as the process is concerned. As far as what we're trying to do to develop an ecosystem for what we want to do. So if it's one project, one product you want to put to market, or if that's going to be the first one that you start out with that gets your feet wet and you want to develop even more, come up with ideas of your own, maybe even do contract design and manufacturing for other people, the choice would be yours. So right now I would say either pause the video or uh, save it and come back to it and get all the anything set up that you want to download and install and work with. Okay, so I put that pause in there on purpose uh, to kind of give you enough time to pause the video or a point to come back to. So now that we've got everything installed, uh, I'm not going to bore you with everything, setting everything up. If you need to know how to configure or install any of these software packages, that's beyond the scope of this video series. There's plenty of videos out there to help you walk you through getting them set up. So with Odo, I will run you through a few things that I say you should change. So once you get Odo installed and it will be running on your system as a service, you'll be able to go to this address in a web browser and bring up Odo. And it typically will bring you to this discuss page. One of the first things you'll want to do is go into apps, and this will list all the apps you can activate. If it says upgrade, that means you have to pay for it. We're trying to do as best as we can to not spend extra money. So pretty much you want to make sure you have sales activated by clicking on the activate. We're not doing restaurant, but that's the button that you would click, activate it. This gets really weird. It's a slow process when you activate because it reloads the whole site and brings you back to discuss. So you have to keep going in and activate, reload, activate, reload, activate. But you want to make sure your sales is activated, invoices is activated, CRM, which is customer relationship management. That's to help you obviously track leads and opportunities. Inventory, you definitely want to make sure inventory is activated. Purchase, because this will help manage your purchase orders when you buy stuff from your vendors. Project is great to help organize your project. Manufacturing, this will help your manufacturing orders and your bill of materials for those, so that way you have your inventory, and then when you go to manufacture a product, you can deplete your stock as you manufacture. It's just a great way to keep organized. And eventually, as you do a business, you will have to, especially if you register as a business and you go beyond the hobby, you'll have to pay taxes on inventory and stuff. So this will help keep everything synced together. Maintenance, I'm using to help create like work orders and service logs for equipment for manufacturing. Let's see, so what else is in here that we want to make sure is activated? There's a lot of this stuff that I would like to activate, but right now it's fine. Everything is okay. Those are the major things that you want to make sure are active in Odo. And if you want to go in, you can go to here, settings, and this is where you can manage your company. You can set your company name, your address. This is where you can set all your templates, the colors for your website, for your Odo site. And one of the great things about this is you can use the online version and actually use it as a storefront, from what I understand, to actually sell products and services. But we won't be using that. But from what I understand, you can use Odo to actually sell online. But this is where you can manage your companies, your tax rate, everything. You could go through and adjust all that yourself. Your units of measurement, things like that. All right. So with that going, we will go to project. All right. There's nothing here. That's fine. So what do we need to do to get this started? So we have an idea of what we want to do, but we also need to take care of a bunch of housekeeping tasks prior to doing all that. One of the housekeeping tasks is figure out how we want to keep ourselves organized to stay consistent from project to project to project. You want to do that from the get-go. You don't want to start working on stuff and then have to try to clean up and organize it later. You're better off using this opportunity to say, hey, you know what? Let's organize this project. Let's organize how we're going to do things. So I've got a folder created already. You just put it wherever you want. But this is where I'm going to house everything for the company. So we'll put that in quotes, for the company. And that includes all the projects that are going to be associated with it, all the QMS documentation, and any artifact that's generated from it. But we will also use GitHub to store this stuff on. So we can use GitHub and their commit logs to help version control, to help make sure that we can stay compliant with ISO requirements, to have version tracking, history tracking. That is a big thing, is make everything traceable. All your documentation, especially pertinent to any product you manufacture, everything that's associated with it needs to be traceable. Version, you need to make sure that you are using the current version. But all this will be covered as we go along. And again, it all will make sense later, I hope. I may not be the best teacher, but we're going to see what we can do. So some of my videos are just going to be me struggling through. I will try to share as much as I can without releasing any personal identifying information. Run through all the processes. But, it's just the way it is. I don't want to try to throw a clean professional video or anything out there, um, because that's not life. Especially when you're starting out, that's not life. That's not how it goes. It's not clean cut. It's not well organized. It's going to be a mess. And this is also a good way for me to get my own personal structure organized, to get myself organized and aligned properly. So as I develop my products and the things I want to do, I can be compliant as well. So it's going to be a journey for all of us. So yeah, I'll have at least the stuff used in these video series on GitHub eventually, and have a link to that, and you can download and edit the files, and I'll maintain intellectual copyright of the devices that we actually design together that I show you about. Um, I'll have a license with them that you'll be able to make derivatives and use them in your own projects and stuff. Maybe even derive from them and sell them or whatever. We'll figure all that out as we go. Not 100% sure how all that's going to roll and work yet, but it's mainly about learning, education, and just sharing the knowledge and experience that I've developed over all these years. One of the things I do want to mention too before I forget is, so I will be Twitch streaming these videos as well as recording them and posting them on YouTube for longevity. Again, I have no schedule set. I will work that out. It will definitely be throughout the weekends, and if it's during the weekdays, it's going to be around 6 p.m. I don't know how long the videos will be. I don't know how much content will be in them. Again, I will do my best to get things organized and cleaned up and scheduled so we can continue this journey together, and you know what to expect. I'm not pushing to do this to monetize anything. As I said before, I do have a career. This is my own side project. I'm not currently sponsored or endorsed, but again, wouldn't be opposed to that. Wouldn't say no. So, with that out of the way, we need to figure out what we're going to do to structure this. So, as I said before, I'm going to use Copilot a lot to help keep things organized. And I'm not going to always use their suggestions, because they organize things completely different. So, again, we have to learn KiCad. But, so in our folders, so we have our Git, and we are going to use VS Code to organize and work with Markdown files. So let me make sure I get VS Code open here. So there are some things I'm going to suggest installing as far as extensions go in VS Code. Some of them are going to be the C extensions. You want to make sure you have those in, because pretty much everything with the ESP IDF is C code, C language. So it's best just to have this stuff installed. You want to make sure you have the ESP IDF actually installed. Make sure you have the latest version that's available. Real easy to install. Follow the directions. There's plenty of tutorial videos on installing it. And then this is a tool I would suggest to use, is this Markdown PDF by Wyzane. It's a great tool, really great tool, that allows you to take your Markdown files and convert them to PDF. So if you need to print documentation for a product, or for customers or an audit or something, boom, you can just convert them, make them nice looking and really presentable. So I would suggest that. I like the code spell checker. That's really great. It'll flag a lot of stuff that's not really a spelling error, but it's really great to help you ensure that you're spelling properly, because I type like a Mac truck and my typing skills are horrible. So I find that to be a great tool. All right, so we're going back to Explorer. Close this guy. So I have just a README file that does nothing, but I have no directory structure set up or anything. No. We can either add it directly here in the folder, which I probably will. So, like I said, I'm going to use, to help, especially when creating the documentation, but I'm not quite keen on this directory structure. So, I'm going to create a folder. We're going to call it QMS. That's going to contain all the documentation for our quality management system. So that's going to be like, a quality manual, standard operating procedures, work instructions, any template that you use to generate any artifacts for testing and stuff, all that stuff. Then we're going to create another folder, and we are going to call it KiCad. And that's where we're going to store all of our footprints and symbols and that stuff. But one of the things I would prefer to do is create another folder. Now I'm going to underscore it and then call it projects. That's where we're going to store individual files for each project. Because again, Copilot's assuming this is just for one product. I want to break that up into the ability to, yes, this is going to be the inaugural project, the inaugural product, but down the road to be able to expand this into other projects and products as we develop. So this will be a starter. I don't know much about KiCad, so I will have to try to understand the libraries. But if it works like Altium, the Altium products, and the Eagle software, you can have one library file contain everything you need for your company. I've never been too keen on a separate library file for each device. In one sense, yes, a separate file helps with versioning, because that library file is only for that. But at the end of the day, that becomes a separate library file that you have to dig through if you're looking for something specific. It's just I don't know if I like that structure, but we'll figure it out. So KiCad, we're going to put we're going to create a components directory, and that's where we're going to store all of the footprints. I think we will just do if it's possible within KiCad, we'll do a mono library file where we'll just have everything in there. That way, it's just, you want to add that, work with it, you should be able to search through it. But again, we'll have to figure it out. I don't really know how KiCad works. We'll get into that into another episode, a later episode. This is just kind of creating our initial structure. So QMS is where we're going to store all of our files. So we're going to start creating some folders. We're going to standard operating procedures, work instructions. We're going to create a new folder called templates, where we will store a bare template for SOPs and work instructions. That way we can keep it unified. from get to go. Let's see, what other things will we need for our QMS systems? We will need a SOPs, work instructions, templates. We will need risk management, and we'll add more as we go. Because SOPs and work instructions will pretty much cover everything. As far as and templates, but as far as files for individual projects, we will store their artifacts in individual projects. So one of the first things that I would suggest doing is figure out how you want your projects to be organized and then document that. So I will want my projects to be organized by, so I'm going to create a folder and we're going to call this P for project 10, 12, 20, 25, 01. And then we're going to give it a name. All right. So the project number would be P101, P10, 12, 20, 25, 01. So the 01 is for, this is the first project created on this date. So if you had an idea for multiple projects on the same date, I would go P10, 12, 20, 25, 02 for project number 2. And then this project number will be attached to every document, every artifact, everything that is associated with this project. The title may or may not, that's going to be personal preference. So we have the controller. So we're going to create a new folder. We're going to call it firmware. And then we're going to create another folder called hardware. Create a new folder called project documents. And another folder, we're going to call it data sheets. Okay, there's a lot going on here. So project documents. So data sheets will be for data sheets that you download, like for stepper motor controller. Project documents will be for things for like a product requirements document is going to be for the block diagram that we're going to draw. But so one of the things we want to do. All right. So it would be best to try to formalize things. So let's come over here. Now, one of the things that's missing out of here, yeah, I'm not too happy with all of this, but let's start creating some of these files. Let's bring up code. I got so many things going on my computer. I'm sorry about that. So we're going to bring up code. And we're going to start creating a bunch of stuff here. So, again, we're going to do things kind of differently. All right. I need, so we're going to we're going to generate a master document list as a markdown file. And some of this we're going to clean up, but this is going to start our master document list, which is essential. This is going to be basically a directory of all the files, everything that is associated with your QMS system, and it will be a living file that will constantly be versioned and updated as you add stuff. Again, I'm going to use Copilot. It's great for building all this. This is all formatted to create nice, pretty tables in code. So we're going to go to our, let's see here. The MDL will also contain other files that pertain to projects. So we're going to go here. We're going to just put it at the root. We're going to call it master document list.md. Or come over here. We're going to paste it over here. Now I'm making this bigger. Yeah, you'll have to bear with me. Okay. All this may be highly disorganized, but if you do a preview, it creates a nice table view. And these are documents we'll build up over time. Let's close that. I don't need that in the way right now. So what we're going to do then is kind of minimize that. We don't really need that open that big. This is just what it looks like. Again, this is going to take a lot of time. So one of the big things is it assumed everything was going to go in the docs folder, but not everything's going to go in the docs folder. Everything going to go in the QMS. So I have to go through and edit as we go and clean things up. Again, this is all a work in process. We're not too worried about being 100% up to date on our versioning because technically we're not becoming ISO certified. But if you ever plan to, everything will be pretty much ready to rock and roll when you go for it. So we have the quality policy, which will have Copilot help us, initially draft up. So this will be the file names that we use, which makes perfect sense. Schematic and PCB revision procedure. Schematic. Okay. Incoming inspection, first article inspection. Okay, that'd be great. So one of the things about ISO is we're going to be using the 2015 revision, which is the current version. From what I understand, there's going to be a new version being dropped in 2026, dropped next year sometime. We're not going to be worried about following its conventions until later. Then once it becomes the current revision, then we'll make sure our processes match and map properly to that. But for now, we're going to be using the 2015 revision. Now, you'll hear a lot of arguments out there from people who just don't know. I've dealt with people like that who just want to cheat and go as fast as they can just to get certified that documentation doesn't matter. Well, yes, the prior revisions of ISO did really focus a lot on documentation. The 2015, the core focus is on customer satisfaction. At the end of the day, if you produce a product, if you have a process, if you produce any kind of artifact, like a checklist, or if you produce a document like a product requirements document, what does it need? What does it do at the end of the day? You're going to produce documentation, so you're going to need a process, a standard operating procedure, or a work instruction that tells you how you generate, how you fill out, and where you store that artifact. So ISO is still reliant on documentation, traceability, version control, and accessibility. So one of the big things with ISO is to control who has modification and editing um, abilities and who can just read and view. That's where GitHub is great because you can control who is read only, who can actually um, write and update files, and it has all that great version control. I'm not 100% used to using GitHub, so that's going to be another learning experience for me, but it's really good for this. Uh, ISO is so big that that's why you typically see at a larger company, they actually have a quality manager uh, job, basically position, because there's just too much for an individual to know. It's just highly involved, way too much involved, way too much you have to deal with, and it's just pretty much its own job. So you're gonna see me fumble and skip and mess things up, but hey, that's part of the process. We're doing the best we can. It's a learning experience for everybody, for you, the viewers, and for me myself. Uh, so again, we're gonna go through, see what we need, what makes sense, rename, change things as we go, as we go. So let's see. Supplier approval and supplier list. That's something we will definitely have to work with. So they want a CSV, which we can use LibreOffice for. Let's see. First article inspection, calibration, test equipment log, risk assessment, and FEMA, um, failure mode evaluation and analysis. These are all things that are important. Training records. Training is a big thing with ISO. Internal audits. Audits are an important thing with ISO. So again, we're going to get all this going. We're going to work with all this, but we may not do everything right off the bat, but we'll at least have the framework. So let's see here. All right. Design decisions. I'm trying to find something that would cover our MDL007. So let's find that over here. Let's have master documents list. So that is going to be, we're going to have that at the root. All right. And that's what this is. So we're going to say it's at the root. So master documents list. So now I have to fix it. So what we're going to do is we're going to copy this. And I think we can go here, rename, bam. There. So now it's conforming to that. So it's, since it's going to contain all the documents and be a list of everything that's associated with the projects, it's going to be right here too. It will grow. The MDL will grow. All right. Okay. Again, because it's called a master document list. This is the first place that an auditor would go uh, to determine, where all your files are located, so they can find them for an audit. This is the first place a technician can go to look for a specific file, a specific work instruction, and everything will follow the naming scheme. It's going to be annoying. Documentation like this will be annoying, and I can understand any complaints to it, but it's just the nature of the beast. It's just the nature of what we're trying to accomplish here. So I don't see So what we're going to do then, I don't see anything for actual project organization. Okay, so generate a I think that's because it'll keep consistent formatting. All right, please. Tables. There we go. I say please. I know it's AI, but you know, at the end of the day, if the machines take over, I want them. I want Copilot to say, "Hey, at least this guy was nice to me." All right, so over here, yeah, it's gonna be crazy. So that's going to be an SOP, and we're gonna call this. All right, SOP. So we're gonna create a new file. I'm gonna call it SOP dash 0 dot md 1 project organization. Now we're going to just copy this. All right. Yeah, see, it's assuming that we're doing one project. To manage product development projects. So let's get rid of that. That makes sense. Roles and responsibility. Project owner, okay, design lead, firmware lead, QA lead. We'll keep all this the same. Project structure and phases, initiation, definition. Okay. Design decisions. Again, this is gonna be involved. We may not do it all, but we're gonna have the footwork, the framework here. Because I don't want to take bore everybody with this huge process, but then again, it's learning. Okay, we might fix all this. Right here, PDFs, repository structure. Alright. Okay, so that we need to change. Okay. So that is going to be a table. Let's make sure that's fine. Okay. Again, we'll go through this. All right. So, all right, repository structure. This is where we're going to will be projects folder with the following. Of month, day, year, XX. Month, day, year, XX, where XX is the XX is the project. That given day. So all right. Use project folder. Organize. Each project folder will be organized. All right, let's go in here. With 4 data sheets. Where the 4 right. Misspelling. Any specific components. Firmware. Any hardware. Bombs. Project management. Again, We can clean it up, format it, make it look nicer in the long run. No big deal. So that gets our first SOP generated. Now, what we need to do then is let's maximize this. Let's get rid of this preview. Don't really need it. So let's go over to the master document list. All right, let's see here. So I can go here. We might be able to organize this. We'll try this. SOPs. One. All right. SOP. Okay. Let's make sure we follow that. Project. Management. Structure for files. Project. Okay, there's that. So, who owns it? So, the person who should own something like this would be the design lead. Yeah, there we go. Okay, design lead. And it's going to be under QML // We're rename. Just Control C. We don't have to. .md, and we're going to call it v 1.0, which is our initial release. It'll probably see some updates and some changes. We're not going to be too worried about version control at this very minute. Okay, so that's a version. Is it controlled? Yes. And is it permanent? Yes. The retention. Because some files you only have to, some documentation you only have to hold on to for X amount of years, like with financial documents, like for taxes, like individuals especially, you only have to hold on to your files for your tax files for like 7 years. The same thing goes with documentation for manufacturing and quality control. Some files are permanent, like SOPs. Other ones are, they have a time, like you only have to hold on to them for 7 years. If you do contract design and manufacturing, the customer will define oftentimes how long you have to hold on to that documentation as per what's called a flow down requirement, something that you may run into in the future if you do this. So there we have our first project, our first SOP. Basic. This is project organization, but the biggest thing was the repository structure. Yeah, we will, like I said, it's going to be a process. So there's a lot to it. That's a lot to take in. And I think so. We've got our first SOP on this, which helps us define our project structure. One of the other things I want to cover real quick is um, so many different directions we can go in. So let's go into project documents. Let's create a draw.io file. We're going to create a new diagram. We're going to do blank because I like doing them that way. And this is just a very general block diagram to help organize a project and help define what we need for it. It doesn't have to be perfect. So up here, the ESP32. We're going to use the one with the IPX antenna, the external. We're using external internal, the IPX format. We just call it an external antenna. This way, you can use extension cables, bulk cables, like if it's an enclosure, to get outside. Or, if you know you're going to be using it, you can just throw one of the cheap antennas, like flex PCB antennas, onto the ESP32 before you enclose it. It's really up to you, but this will give opportunity for development, other things we can do with it. So we're going to have an external ESP32 antenna. All right. So what we're going to do then is we're going to go to Mouser and we're going to actually pull up ESP32. Which chip is it? Which one have I been preferring to use? ESP32 dash room dash 32. I think it's the U. I think it's the U. I think it's the H4. I think it's the H4 that we've been using. Let's see here. So what we're going to do is we're just going to copy this because it uses the IPX antenna. So we'll go back to draw.io. Let's drop the. Oh, okay. I don't like that. So wait up. Nope. All right. So I don't like that. Dash. 32 UE. Call it use the H4. Okay. All right. Let's make this guy a little bit bigger. All right. Okay. So that's going to be our core. So like I said, there's going to be a block diagram. Now, so it's going to be using the DRV8825 PWPR, this stepper motor driver, which is really great. I've used it in several other projects and really like it. Plus, you can get dev kits off of Amazon to test with it. So it's the DRV8825PWPR. Okay. Okay. So now we're right over this little guy. Because there is going to be some bidirectional communication because no, actually, yeah, there is. So it has fault detection, so we can use that. So you can read like the fault detected. It's a generic. It'll be either in a fault condition or not, but at least it can tell the ESP32 that there is a fault, like overheating, overcurrent, etc., etc. So there is going to be some bidirectional communication, but it's going to be very limited. Most of it's going to be ESP32 is going to control the driver, the stepper motor. But we're going to need. We're going to have we're going to have limit switch inputs for if you want to use this in like a gantry that goes back and forth. We'll at least have them to like an inner and an outer. It can be customizable. So we'll have limit switch inputs. We are going to draw them. So one of the goals is to be able to operate this device on 12 to 24 volts. Obviously, you need 12 to 24 volts for the stepper driver. It operates on that voltage range. I think it'll go up to like 24 or 48 volts, but the typical range is 12 to 24. So we'll want that capability. So we're going to need limit switch inputs, and we're going to be opto isolated, which they'll be okay working at a 3-volt range, but we're going to assume automation 12 to 24 volts. So we're going to do opto isolated limit switches. And then I got to remember the opto isolator. AC. AC opto isolator. I might just have to pull up some documentation from previous projects because there's what is which one do I like to use? You know what? All right. So I'm going to look in some of my other folders real quick here and pull up the documentation. Pull up a PDF file for projects I've done in the past. Only because I can't remember. There's an opto that I like using. It's really, really universal. I'm really happy with it, so I want to kind of keep just stick with it. So one of the things that I do recommend is kind of standardizing on parts too. That's a real big thing I would. Okay. So TCMT 1600T3. All right. There we go. Now we got it. So it's a TC. Okay, so it's an AC input, so you can operate it via an alternating current or a direct current, which is great. Single channel NPN phototransistor, so it's a really great universal drop-in. Really great to use in these kind of control projects. And all you do is we'll build up the circuits to control it. But TCMT, let's minimize this. Put this in here, TCMT 1600T3. All right, so that be our limit switch inputs, and you can use them as outputs too. All right, so that'll be our limit switch inputs. Oh yes. We're going to have a power supply. We're going to have power supplies. We're going to have a 3.3 volt, which is going to be a switching unit. And And I'm sorry if you hear me burping. I apologize. We will try to edit that out for the YouTube video. Okay. So, for that, I have a few chips that I want to use that I've used them before. It makes it a little easier when you know what you want to use because you've already used them before. All right. And I like them. They're real easy to integrate. But let me get find the right part number for this. So, and we'll build around everything. Okay. 3. Okay. This is going to be EP. And this is going to build. So what's great about this particular unit, AP 63205. So these are fixed switching regulators. They are capable of up to 32 volts input, and so the 203 version is a 3.3 volt output at 2 amps, and the 205 version is a 5 volt at 2 amps output. And the only difference between their circuit and their layout is the actual switching regulator unit, but they can use the exact same inductor and capacitor format for both of them, so that simplifies laying out the circuits. Really nice. And their voltage range makes them really good. They're buck regulators, they're not boost. So before we get too far, we're going to file, we're going to save as. Yeah. It's hard trying to keep everything organized and separated. I gotta figure out where my files are. Yeah. All right. Save as. V. We're gonna call this. Let's see, operational. P 10 12 20 25 01 operational block diagram. All right, so that's what this is, and we've saved it in the project folder. So as part of the project documents. So let's see here. There we go. So that will feed pretty much that, and everything comes off of that. Blah blah blah. So we have our power supplies. You know what? So we have better control. There we go. Much better. Okay, so we have limit switches. I'll delete that because I'm going to move this up because there's going to be a lot more things we're going to want to do to this guy. Limit switches. So we're going to do RS 485 communication to make it easier to incorporate into other into devices. So we're going to do use an RS 485 half duplex chip. Oh, use the RS 422 485 SMT. I personally like analog devices. Actually, Max Linear makes a good one. So we're going to go here. We're going to do a SOIC 8. Simple. All right. Okay. All right, let's see what we got here. It's 45. There we go. Very good. So that is going to be the RS485 chip that we're going to use for this. SP485 REN dash L/TR. So we have RS485 communication. RS485 will allow us to multi-drop and be able to communicate with multiple devices in the same system. We could go with CAN, but RS485 and CAN not too terribly different because CAN's a protocol that was built technically on RS485. It's very similar in function, and I just like RS485. Plus, we can kind of write a console on top of it if we really wanted to. We can build up like a command and control console and actually have it incorporated into the functional. We'll figure all that out. So we have our RS485. We got limit switches. Let's move this guy back over here. So then we're going to throw in here too. I don't know if we're going to have direct control, but I'm just going to kind of throw it up here because it's going to come off the power supply. We're going to have a fan to help keep the stepper motor driver from overheating. I don't know if we're going to control it in any way yet or not, or just have it constantly running since it's going to not be battery powered. We can figure that out. We can always put a low side driver circuit on it if we really want that. So let's see here. What other things do we want with this guy? Switches. So we want a couple of inputs, control inputs. Don't know how many we want yet, but and they're going to be opto isolated as well. And they're going to use the same TCMT T3 opto isolator chip. Again, we are building a mystery here. Control inputs, opto isolated. Okay. So probably like an enable direction controls like forward or back. We could even have even the limit switches could be other kinds of inputs through say like photo detectors. Not 100% sure what direction we want to go in. We can set the limit switches to be able to be like photo detectors. We can always figure all that out. Control inputs. We're going to put there we go. Make sure we clarify that. All right, let's see here. What other things do we want on this? Now, one of the options that we can do is on the air, over the air firmware updates. I'm not 100% sold on that, but that's something we can do later if we decide to. Because with a firmware development, I want to be as modular and drop in as possible. So the reason for this block diagram is like I said before, anybody might be just joining in or whatever. It's just to help organize your thought process and how the project's gonna shape out. You give you an idea of the components you want to use on it. All right. Okay. What other things should we have? Control inputs. Function. Enable. And that can also be overridden by RS-45, but these will be physical inputs depending on the type of project and the actual application for this. Like I said before, it's just annoying every time I want to work with a stepper motor. I've got to break out, get a breadboard set up, get all this stuff set up. This way I can have everything ready to go. And I could just start programming or developing or already have one I can drop into a project and test stepper motors or whatever. All right. So that kind of sets the block diagram, the operational block diagram. And I spelled the file name wrong. I get that. That's that's me. Yeah. That's pretty funny. I'll fix that real quick. But we'll go and we'll save it. We'll close it. Go into our project. And that rename diagram. There we go. I'm just gonna get rid of that. Open that back up into draw.io. There we go. All right, perfect. We fixed that problem. Okay, that should do it for the block diagram for now. The main goal is just to get an idea of what the direction of the project, and this will also help us figure out our product requirements document, and then we'll fine tune this based off of that. So that would be for that, and I say that We could end the video here and the stream here. Covered quite a bit um, because the next stage will be getting the product requirements document built and drafted up, so we know that'll become our, lack of better terms, map that we're going to use to help shape the direction of this project. We're going to start using Odo and enter some stuff into Odo to help keep us organized. Uh, so hopefully, yeah, we'll start using the project management, get organized, and figure out everything from there. All right, well, thank you for watching this video. Thanks for watching on Twitch, for catching me on the stream, and hopefully I'll have the YouTube video edited and uploaded with links to the software and other things. Thank you, and have a great day.